Okay, so let's see. A hyperopia we are talking about is with 100 degree. So is that clear or blur visions? What is accommodations? So like the hyperopia, the definition is when the light coming from right through the either at the lower power of the corneal lens, they are focused not on the retina, they was behind of the retina. So therefore we call the accommodations. How do we correction it? Because if we don't correct it, they will have very long focus. They have the less refraction power. So we are using the convex lens. How this work? Because if you put a convex lens, actually you put the more focus power here. Therefore, they can refocus back to the retina compared to this. So it's opposite to the myopia. It's very easy to understand. And the corneal shape actually, so this is hyperopia and myopia. Then we're going to, in the rest of the class, we are going to another idea called astigmatism. Astigmatism compared to the, we just talking about myopia and hyperopia because there was some different. In the cornea, we can summary to two axes. One is horizontal, one is vertical. So if they have the same the power, they should both focus on the retina with one point, or called one focal point. However, in the astigmatism, as our student understand, they have different power in the different meridians, either maybe the corneal problem or the other problem. For example, in the horizontal, which is purple, they have more power. They can accurate, maybe focus on behind, or sorry, or less power, they have focus behind of the retina. However, the green plant, which is vertical, they have more power, right? They focus in front of the retina. Then they will making the different two plane. They have the called multifocal point. So this is where the astigmatism coming from. So astigmatism is condition eye, light into the eye is not equal. This is important, not equal in all directions. How do we understand that? Here, I make a movie and some cosmic. Here is the all the meridians or all the axes of the eyeball. We can separate by two. One is horizontal, one is vertical, right? If the cornea is spherical, we can see the vertical, which is red, right? The perfect focus on the retina. In the horizontal, which is also can perfect focus on the retina. We call that the normal, or in the spherical cornea. That means all the directions are equal. However, if not all the directions are equal, like this, when they have more power, remember, they making the more power. The meridian either is a vertical or horizontal. They have making the first fault line, which is red, show here. If they have the circle, they making the shape change. In another meridian, either the horizontal or vertical, let's see here is vertical, which is purple, they are making the less power, which is behind. This is the focal point, making the second focal line. Therefore, because they are different axes, they have the different power, so they making the here. Normally it's two focal plane. Even it is red. However, this two plane is not that red, right? It's like ellipse. So if there was red, they should like this. They should like this. However, because their power is different, so they making the two different power meridians. So that is where the astigmatism is coming from. So astigmatism actually usually is never by him alone. Very seldom. Usually is with the myopia and the hyperopia. So if they with the myopias, for example, like this, two different, they call the compound myopia. However, it is only myopia, we call the simple myopias. If the two focal plane, one is in front, one is behind, we call that mixed, okay? The same, if there was only hyperopia, they have the simple hyperopia. However, if it's both behind that, we call that compound hyperopia, right? So the compound myopia is both meridians are myopic in front of the retina. Simple means one is myopia, another one is on the retina. Mixed means one is in front, one is behind. Actually, one is myopia, one is hyperopia. And compound is both is hyperopia behind our retina. Simple, one is on the retina, one is hyperopia. So this one, I hope our student to remember this. So classification of the astigmatism, they should by the orientation of the principal meridians and the source of the astigmatisms. So principal meridians actually is called the radian of the curvature. We divide by the horizontal and the vertical. If the horizontal and the vertical, they have the same power, the ball is like a football. For example, if some meridian have more power in here, the vertical they have more power, in the horizontal they have less power, this ball will be changed to a football, American football, because in the vertical they have more power. So the principal meridian here is a little bit different. So they are making the astigmatism. So when RH equal to RV, this is spherical. When RH, the radian higher than RV, the short radian means they have more power. So this is short, so they change more, right? So this is RH bigger than RV. So 90 degree to each other. This is a classification of the astigmatism. In the last two lectures I talked to you, when we're talking about the corneal topographer, we know the astigmatism most is coming from cornea. We call it anterior corneal surface. And another astigmatism called residuum, including the posterior, anterior lens, and the posterior lens, vitreous, and retina. All this called residue astigmatism. And the regular astigmatism, including everything. Corneal, lens, retina combinations, we are calling this regular astigmatism. However, if only coming from cornea, because the trauma or everything make the cornea is not flat, we call it irregular astigmatism. All right, so they have the different classifications. 90%, or I'm going to say 95% astigmatism actually coming from the cornea, because the cornea has problem. So here, let's talking about the with the rule and against the rule. All right. So there was two principal meridian lying in the 90 degree. We are called regular astigmatism. So what is the with the rule? With the rule is horizontal. All right. Horizontal. I always using my hand. So this is 0 to 30, 180 to 150. We call the with the rule. Against the rule, which is green, like here, 60, 90, 90 to 120 with against the rule, making your sum up because our student like against. So against everything is good. So we sum up. So this is easy for you to remember. Between them, we call the oblique from 30 to 60 and 120 to 150. We call the oblique axis. So how do we show that the with the rule astigmatism? With the rule actually is with the rule is vertical meridians. They have more power, more curve. So axis of the cylinder should be this one or this one. I don't know why our student always have some students remember 180 plus minus 20. This is wrong. Okay. So remember, please remember is this plus minus 30. This is right. This is right. Okay. With the rule, which is horizontal, that means in the vertical, they have more power. So this is which is right, have the more power in front of the retina. So this is show you with the rule. Okay. And against the rule is horizontal. Horizontal have more power, more curve. There was 90 plus minus 30 degrees. So in the horizontal, they have more power. In here, horizontal, which is purple, which is in the focal line, which is in here, the first one. This is against the rule, which is a power plane, which is horizontal. Remember that. So let's say that again, oblique, which is 45 or 135 in here. So when we see the corneal topographer, you can see clearly this is the power is here. This is axis, okay? Oblique. So if this is cornea, and with the rule, which is horizontal, what will be happen? Horizontal, they have more power in the vertical. So this is a perfect football against the rule. Against the rule, axis is here. They have more power at the horizontal. This one, for some reason, older people is more, and with the rule, the young people has more of this astigmatism. Okay. Among the astigmatism is the difference in reflection power in two principal meridians. For example, with the rule in the vertical, they have more power.